afternoon, everyone. Thank you for coming for the second day of the webinar. Today, let's welcome the speakers from Beyond Zero Emission, Supermicro, and Seagate. Enjoy the day. Thank you.
All right. Hi, my name is Dr. Chun Hin Ng, and I'm from Beyond Zero Emissions. Thank you to DiGiCOR today for inviting us to present our renewable energy industrial precincts at this lovely workshop this afternoon. Before I begin, I'd just like to acknowledge the Bunurong people of the Kulin Nations, the traditional owners on the lands in which I both live and work. And I'd like to pay my respects to the elders past, present, as well as emerging future leaders. So yes, as I said, I'm here to talk to you about renewable energy industrial precincts. And it's quite an exciting idea, so hopefully you guys will get a lot from it as well. For those who don't know, we're here at Beyond Zero Emissions. We're an independent, not-for-profit climate change think tank that have a small team of dedicated staff, as well as a vast network of volunteer experts who mainly focus on showing both governments, industries, investors, and communities how Australia can prosper in a zero emissions economy. And we do that through a lot of our own independent research, as well as talking to a lot of different experts in a range of sectors on ideas, innovative solutions for both manufacturing, renewable energy, land use, housing, a whole range. So here you have our team from a little Zoom meeting, and we regularly produce reports, and two of which are here. One called Electrifying Industry, that we sort of highlight how we can transition a lot of these sort of gas-intensive or energy-intensive industry processes into electricity, which can then run off, of course, renewable electricity. And also this 10 gigawatt vision for the Northern Territory, which was quite pivotal in the 2019 Northern Territory election, where this report helped get all major parties participating in that election to sign on to 2050 targets for emissions, which we did not imagine would have been possible, especially for some of the parties that were out there, and just really highlight the opportunities that renewables can bring. And so in the past year, our biggest report has been the Million Jobs Plan. And if you haven't heard of it, it's a plan that shows how in our COVID recovery, we can really focus on using renewable energy and this idea of a green transition to produce over 1 million jobs. In fact, we found 1.8 million new jobs across a range of sectors. You could see here, building new renewable energy and transmission lines, retrofitting houses to make them more energy efficient, to transportation, to manufacturing, to land use and how we can change the way in which we manage our land and use it to sort of capture carbon, and also, of course, how we can sort of really promote the recycling and circular economy, and all the opportunities that are there. And this report got picked up by quite a lot of different press, and we've really made a big effort to sort of highlight, especially in more, I guess, not traditionally renewable friendly sources, like what renewables and zero emissions can actually provide, like the opportunities rather than the scary sort of things that have been talked about in the past. And so it really shows that the job opportunities are out there, and you can use that to boost growth and prosperity, and really a lot of new innovations and technologies that's out there. So from this, we were able to brief Energy Minister Angus Taylor, as well as the Prime Minister's office, and we put in a budget submission, and we actually saw quite a few of our suggested policies to be implemented, both federally and across the different states. And as part of the briefings to Minister Angus Taylor, they were actually shown quite a lot of they were quite curious into our manufacturing plan. And so this is where then it evolves and developed into a full-blown renewable energy industrial precinct. And this was briefly touched on in the Million Jobs Plan, but really got developed out and will form one of the big focus for us this year. The idea is quite simple, but quite ingenious, I think, and quite a neat solution, where you get a cluster of manufacturers, hook them up to renewable energy generation as well as storage, and you fully electrify them, allowing them to power everything using renewable energy. And so as a result, have zero emissions manufacturers. Now these can be connected to renewable energy zones, a lot of which have been announced in the recent year or two, and really provide that big generation capacity that's needed to transition a lot of these industries. And it also opens up a lot of export opportunities, especially as the world moves towards more zero emissions demand. And so yeah, I mean, it is coming, and my next slide will sort of highlight this. A lot of these demand for low emissions, or zero emissions, I should say, a lot comes from the companies themselves, which really see climate change as a big motivator for them, and really put in strong targets, much stronger than a lot of governments out there. And so big names like Toyota and Apple and Microsoft have all put in emission targets, both for themselves, the direct and indirect emissions, as well as their supply chain emissions, or scope 3 emissions. And that means all their suppliers from upstream of their processes, as well as customers downstream of these companies, will start to get pressure from the companies themselves to sort of shift towards zero emissions. Whether that's, say, in Toyota's case, sourcing aluminium and steel from processes that are more green, that are more powered by renewables, to actually producing zero emission cars for customers to drive. So that's the hydrogen or battery sort of powered cars, and that's rapidly growing. I did a bit of research as well, and some of DiGiCOR's own customers and suppliers have their own scope 3 emission targets, including Seagate and Intel. And there's a really growing movement within companies that seeing this both as an opportunity and as something that they need to do, both for shareholders as well as for the good of their own company. I will say just briefly, BHP did a study, and they found that in a world where they don't take strong action on climate change, they actually lose profits. And so, you know, if that's not a motivator for companies to get on board, I don't know what is. And so there's a really big push for this. And of course, it's reflected as well through investors who really see fossil fuels and sort of carbon intensive sectors as more and more of a risk these days. And so far, over 14 trillion have been divested, and it's growing. And when you look on the other hand for a lot of green, like green investments, that has really taken off in the recent years. And lastly, countries are also really putting out the pressure for us to sort of transition to zero emissions, especially with the recent announcement from Japan, Korea, and China. All of them are, you know, big importers of Australian products. They have all announced zero emission targets by 2050 or 2060 for China, as well as EU, US, UK. There's so much pressure for Australian manufacturers to really move their processes towards lower emissions and zero emissions. So this demand is going to be a massive market. And yeah, I will say, of course, Australia is perfectly positioned to really make the most of this opportunity. We have one of the best solar and wind resources in the world. And all it really takes is good planning to provide some sort of investment confidence, as well as confidence for companies. But in terms of resources, Australia is top notch. It's hard to find a better place than Australia to really capitalize on this and become a renewable superpower, much in the same way the Middle East was able to capitalize on the discovery of oil to really power their economies. Australia can really make the most of the renewable energy that's being dumped on us to go fully zero emissions. And so it's out there. Everything is in place. We just need to do it. So yes, we've identified a range of locations all around Australia. Just to highlight a few, sorry. We've currently focused our efforts for the Hunter Valley and Gladstone regions, both because we have volunteer and staff based there, but also because they are old industrial hubs that have a lot of existing industries that can benefit from their transition. There's workers there originally in fossil fuel industries who would really benefit from a transition to zero emissions industries. And there's also a lot of skills from these workers that will help us really make the most of these new renewable energy industrial precincts. And so the opportunities come from whether it's using hydrogen and electricity to produce green steel or green aluminium, to producing and exporting hydrogen and ammonia, to really electrify all of the mining and industry processes to allow them to become zero emissions, to a bunch of new clean tech sectors such as battery manufacturing, wind turbine manufacturing, EV manufacturing, and sort of maintenance as well. These are all massive opportunities that are coming up. They're going to be the real big sectors and big opportunities for industry. Yeah, like I said, it's just for us to take. And so that's sort of where our renewable energy industrial precincts come in. By hooking up all of these zones with renewable energy as well as storage, we're really able to capitalize on these fantastic new industries and really become a manufacturing and renewable superpower again. So this part, I tried to tie into some of the more information and communication technology audience out there. I will admit it's not our traditional audience, and so hopefully this is helpful for you guys, and hopefully I don't say anything that that might be not quite making sense, but I'm sure you guys will point it out as needed. But going straight into it from the very top, when it comes to the powerhouse of the renewable energy industrial precincts, degeneration, ICTs already play a big role in terms of optimizing individual like wind and solar farms, when to turn on, when to turn off, how to make the best use of sort of the pricing mechanisms that exist in each sort of country or state even. And combining that with sort of like weather information. And so ICT will continue to play a big role there. But more importantly, as we sort of connect these resources, these generation resources to sort of storage, like pumped hydro, utility scale batteries, and even domestic PVs and domestic battery storage, and of course hydrogen, there's a lot more opportunity there for them to interact and really optimize a lot of these these interactions. So whether it's sort of knowing when a pumped hydro facility is full or low, sorry, excuse me. When is a good time for them to really put power in to help pump it up to recover the storage, or whether it's already full and perhaps it's best to use that energy into producing hydrogen, or other sort of or chemical manufacture, or just powering high energy processes that might be needed for the day, to really sort of communicate through that grid and transmission network, and really optimize all of these possible effects across the entire grid. And so ICTs will be definitely needed there. And I guess this ties into the next slide, where we really want a sort of a smart grid system where it's not just the generators and the storage facilities. You also want to be able to adapt to sort of end users as well. And all of these rely on good ICTs processes in place and systems. So we really help it make it dynamic, able to adapt to the fluctuations that occur naturally, of course, as we move to a more distributed energy network. Of course, past issues that I've highlighted does include sort of voltage and frequency fluctuations, where voltage might go too high because there's the excess of solar that can also cause damage to equipment, or of course where it's too low and you like experience blackouts and brownouts and things like that as well. And so the ability to really monitor and communicate that across the entire grid would really help us be able to sort of ensure that reliability and efficiency that's needed for especially manufacturers, which rely on sort of stable, consistent energy inputs in order to do their best work. And it also just helps for all of the participants in the network, from generators to storage, to really make the most of any of the pricing mechanisms that are out there. And so ICT will definitely come into play to really build out this system, whether it's collaboration through AEMO or whether it's through individual wind farms, solar farms, hydrogen facilities, all of that transmission networks. They will all come together, and we'll just need a smarter grid in general to really, make the most of this new style of energy that we're going to get, rather than just traditional concentrated little hub for, like, say, coal plants. And so within going into the precincts themselves, there's a lot of opportunity as well. The idea for the precincts is kind of highlighted here, where they will be clustered into a relatively localized area. And within that, you'll have high energy consumers, whether it's for green steel or aluminium, as well as sort of the more traditional factory and warehouse businesses, say for battery manufacturing or electric bus manufacturing. And so there's a range of different power requirements there. And so ICTs will come into play to really help make the best use of this cluster. And so starting with the big manufacturers and the big energy consumers, one of the big things they can get involved in is demand side participation. And this is something that is mentioned in AEMO's 2020 Integrated System Plan. And so you can see the quote, demand side participation across the NEM is forecast to double by 2040. And this is only in their central plan. They have a step plan, which is expected to quadruple, so even higher. And all of that will be driven by advances in information and control technology and by market reforms. And so at Beyond Zero Emissions, we're trying to work on the market reform stuff. But of course, from you guys' side, the players in the information technology market, a lot of these developments and the ability for industries to take advantage of this demand side participation really comes from companies adopting and also like new advances in these technologies, in how they communicate and how they sense, in how these networks are built as they become smarter, and as you get better access within the cloud and sharing information. Although those systems and infrastructure will be a big part of how renewable energy industrial precincts will work. And I mean, like, just to highlight how big an effect this demand side participation can be, Tomago, the aluminium smelter in the Hunter Valley, uses approximately 10% of New South Wales' entire electricity. And so this has happened in the past. Occasionally, when the demand across the grid becomes too high, there's an opportunity for these smelters to ramp down their production, allowing excess electricity to be fed back into the grid. So you then maintain the stability for a big base of audience. So yeah, across all the customers. Sorry, recovering from a cough. Not COVID, but it's a bit annoying as I'm talking a lot. So apologies for my coughing. But anyways, yes, aluminium smelters are a fantastic example where they can adjust their demand in order to help support the grid. And there is already a pricing mechanisms presented there that allows them to really take advantage of this. And so in the future, by implementing sort of retrofits such as NPOT, which helps to maintain temperature and maintain usability of the separate pots, the aluminium smelters are able to participate more in this and take an active role in adjusting the demand side and help regulate and provide that reliability across the entire grid, as well as, of course, within the industrial precincts themselves. Another opportunity for these big consumers is to have their own generation. And a fantastic example is the Sun Metals zinc refinery in Queensland, where they've actually recently put in their own solar farm that generates electricity for their production. And of course, ICT ties all this together by allowing these companies to monitor their own usage, to allow them to communicate with what the grid is using, and sort of really try and figure out what are the opportunities there for them to either ramp down or ramp up production to provide that stability and be rewarded for it. Of course, you know, like they says, market reforms are needed, but these are the opportunities that are there, and it's already happened. And it just needs a way for us to formalize it and really scale it up and normalize it across the entire grid and the industrial precincts. So for the smaller manufacturers themselves, the ability to move towards smart factories using ICTs really allows us to make the most of these renewable energy industrial precincts. And so I've highlighted some of our sort of partners and companies that we help advocate for. So one is a battery manufacturer at Renaissance One. One is a hydrogen storage supplier at Lavo. One's a electric bus manufacturer, and MGA Thermal, which allows these little bricks made from like recycled materials to store heat, industrial heat, to use for a whole variety of purposes. And so all of these companies are able to really benefit from a renewable energy industrial precinct by tying in their products as well as their production facilities into zero emissions power, and really help make it more automated, and also allow them to sort of optimize for efficiency. And because they are also, the idea is for them to be located within a central precinct, you'll be able to share resources, whether it's electricity or heat, water, waste and recycling infrastructure, and of course, hydrogen infrastructure, which is a fantastic sort of buffer that allows these zones to, you know, build up storage through hydrogen while there's a lot of renewables production out there, say on a sunny or windy day. And then on days where, or nights where there's less power coming in, they're able to then use that hydrogen and to maintain the electricity supply. And so having that in a centralized precinct really makes that whole process a lot more efficient. And so at the end of the day, they'll be able to have much lower running costs, as well as satisfy that global market demand I talked about, where all of these zero emission goods will be paid for a premium, and be able to export all around the world without any risk of sort of carbon tariffs or any other future pricing mechanisms that countries might want to put against more carbon intensive industries. And so that's pretty much, yeah, for renewable energy industrial precincts. That's a lot of the advantages that they provide, and as well as how ICTs can really come in and help optimize all of these processes. And so I'd just like to say, in terms of what Beyond Zero Emissions is doing, we're briefing currently parliamentarians on the idea, as well as industry like you guys, and also investors, to really showcase these opportunities out there and to get support, to whether it's policy support or just sort of industry support, to really say, hey, this is a fantastic idea and we really want this to happen, and to really build up a consensus about how we should go about this. Like I said, we've focusing right now on the Hunter and Gladstone regions, but there's no reason why this can't be rolled out all across Australia. And so right now we're launching a website to sort of gather this support and to sort of showcase what's available and what can happen. And we really want to push for this renewable energy industrial precincts to occur as soon as possible, because all around the world, countries are doing similar things, especially Europe and UK. And it's, even though Australia has a massive advantage in renewable energy, it's not going to take us so far if we dawdle on this, and the other countries are able to get their infrastructure, to get their skill sets from their workforce up, to get the technologies, to get the investment there. where it's not a 100% win for Australia if we don't capitalize on this opportunity now. So we really want to make a push for it. And of course, these all perfectly tie into government initiatives. So that modern manufacturing strategy, the hydrogen strategy, as well as the low emissions technology statement, where it touches on things like energy storage, hydrogen, low emissions materials, which is green steel and green aluminium, as well as just making industries more advanced, more efficient. Anyways, the concept is there, and the opportunity is for us to take. And so I'd just like to end by saying that we are right now gathering expressions of interest or statements of support to put onto our website to share with politicians. And so if any of you guys would like to sort of get in touch to sort of discuss opportunities there, or just want to talk about this idea, this renewable energy industrial precincts, as well as sort of come to us about I guess what ICT can bring, I will say it's not an area that is my expertise. And right now, unfortunately, within Beyond Zero Emissions, there's a little bit of a lack of insight into that area. But we're more than happy to sort of talk with industry to really understand the needs and to how to make this happen. For you guys, so policy asks, what kind of funding, maybe even just sort of like industry standards that really help the technology sector get on board with renewable energy industrial precincts and realize those opportunities. So please feel free to contact me at industry at bze.org.au and just attention me. So that's Dr. Chun Hin Ng. And yes, thank you very much again for this opportunity to talk, and happy to hear any questions. Thank you very much. And I'll just stop sharing now.
Hello, I am Vik Malyala. I am a Senior Vice President of Field Applications and Business Development here at Supermicro. I'm here to give a brief presentation about upping the performance ante while keeping the IT green from Supermicro's perspective. A quick background on Supermicro. We are founded in 1993, and we started with developing core logic for Intel x86 platforms at a motherboard level. And over a period of time, we have expanded our portfolio to cover a wide gamut of product line through the development of the motherboard, the chassis, the power supply, the BIOS, firmware, and the software management tools and service and everything bundled together to take care of customers of any size, starting from a small system integrator to a hyperscaler, an OEM customer, to somebody in the deploying systems at the edge. Being in Silicon Valley gives us the advantage of working with all the industry leaders and technology partners to bring the technology first to market. And that's been the core competence for Supermicro since the very beginning. And we do that by having so-called application optimized server building blocks, and by putting them together, which I will go in little detail later, to get the right value for the customers. Green computing is a very important initiative for Supermicro, and we are able to get that performance without compromise on anything while keeping the earth green or the compute green is what our initiative is. We are number 5th in the server vendor in terms of the volumes measured by IDC, and we did about 3.5 billion business last year, and that's about 1.2 million units that we shipped. And we have a strength of about 4,000 people. About 1,700 of them are engineering staff. And we take pride in providing the industry's broadest product portfolio, thus by addressing different workloads. And over a period of time, we've been investing in expanding Supermicro's presence worldwide. In terms of our manufacturing capabilities, our support and service infrastructure, as well as helping us to enable customers that are worldwide, whether they are in different geos or the multinational companies that have a need to be supported and supplied product worldwide. Fast forwarding to 2020, which is this year, we have the global expansion with headquarters in San Jose and our manufacturing facilities in Taiwan for the Asia Pacific operations and from Netherlands for the European operations. As I was mentioning, one of the key differentiators for Supermicro is a bottom-up approach. What we do is we look at the product design, and when we have to support a wide gamut of products through a vast product line, one of the ways is to do the building of all these components ground up under one roof, and we are able to put these things together to come up with the right combination for the customer for a given application. So for example, we have like few hundred motherboards and the enclosures and the power supplies to go with it. And if you think about the rest of the components that make the server on a hardware level, which is the riser cards, the add-on cards, the back planes, and heat sinks and whatnot, all those things put together, we can come up with thousands of combinations. And given a specific customer and what kind of problem that they are trying to solve, we will be able to put these things together with the right certification for a given region or if a given application. We'll be able to do that and get the right solution for the customers. This has been our success, and this has been our mantra. As I was mentioning, the expansion for Supermicro's thing came from initially their subsystems, then moved into servers, which basically some of them are quite famous. For example, the Twin technology, we were the first to bring to market back in 2007. And similarly, in several other areas, we are able to differentiate, bringing new technology and enable the customers with the right technology. And as it gets adopted, pretty much others also adopt the same. Today, the systems point of view, we are able to put them together in a rack level with the right solution, with software partners working with us to get the solution level deployment for the customers, including support and service. And one of the most important things is to build all these things based on open standards, which is where we try to take, whether it's the hardware or the software or the system management utilities, we try to make sure that our systems are designed keeping open standards in mind, as it becomes much easier for people to adopt these, and it's also compatible with what else is developed in the industry. That way, people don't necessarily need to have a vendor lock-in. If you take a look at some of the things that we have been doing, a part of it is also kind of connects with the open compute initiative. One of the things we have taken is majority of the customers are actually having a limitation in the amount of power per rack in a data center. They have restrictions around cooling. They have restrictions also in going with in dealing with very limited IT staff to customize or to make any experimentation on that. So if we are able to design platforms based on open standards, in this specific case, for example, Open Compute, one of the initiatives is the OCP 3.0 mezzanine for the networking connectivity, whether it's PCI Express Gen 3, Gen 4, or Gen 5. You can actually have that both backward and forward compatibility while giving people an opportunity to service them easily in the industry. So as the systems get deployed in a data center level, especially in a hyperscale or tier 2, tier 3 type of cloud service providers, it becomes important for them to be able to service it with minimal effort. People don't need to necessarily open up the boxes and then go with that. So that is one of the standards we adopted, in addition to having a standard PCI Express add-on cards. Similarly, when you take a look at system management side of it, one of the things that people have adopted is Redfish as an API. Good olden days, it was all about using a baseboard management controller and having an IPMI as a standard. But as the number of systems increase, we started to add these features, that way, whether it is Supermicro or some other vendor that is going to be supporting based on these open standards, people can manage the systems. Yet another initiative is OpenBMC, which actually is being heavily I would say, asked for by tier 2, tier 3 CSPs in order to manage their system management and have their own particular tool set developed around it. These are all the open compute initiatives that we are taking and incorporating into the standard 19-inch rack form factor systems. And, case to point is we're talking about, how do we make these systems, available in volume, and how do we make it easy to deploy? How do we make it easy to manage, both in terms of hardware management as well as system updates and whatnot? Standardizing on the bill of materials is what we looked at. In case of a cloud DC product line, where we are supporting 2 of the OCP 3.0 mezzanine cards in the system in a dual socket type of platform, and the same thing can support certain add-on cards and have a very high efficient power supply. This is one of the things available in a 1U or a 2U type of form factor. So no bells and whistles, keep it simple, and support the open standards, be able to go after different type of workloads within a specific data center. The other option is Mega DC. So one is about deploying standard workloads, and the second part of it is whether you want to have your own compute intensive workloads, or you want to have something for your storage, big data analytics, or you want to have some VDI, or you want to have machine learning type of applications. These are all the different ones. And instead of having multiple different platforms with its own motherboards and other components, it makes it difficult for people to manage the inventory and be able to support and service them, especially for people who have deployments that are not necessarily centralized. In one place, if you have thousands and thousands of systems, it's relatively easy to manage them, versus people looking at deploying it in different areas, different regions that are geographically separated, and some could be in colo facilities and whatnot. How do we ensure that we are able to service them properly? So Mega DC is a product line where we kind of minimize this overlap. So the one motherboard is designed to take care of different form factor platforms, whether it's a 1U with NVMe, 1U with a lot of storage, like a 12 hard disk drives for and some NVMe drives for some Hadoop type of workloads, or a system with a lot of add-on cards, including a 2U form factor with some GPUs for VDI or machine learning type of applications, depending on which one you plug in. This way, what happens is that we are going to standardize on a single baseboard, so the qualification becomes easy, and if anything need to be serviced, it's much easier. Like with anything else, this is also going to support OCP 3.0 mezzanine card, as well as OpenBMC on this one. OCP 3.0 mezzanine is a standard, and Supermicro has an extension of that called AIOM, Advanced IO Module. What it does is, using the same connectivity and everything, we'll be able to work with the existing products available from different vendors, as well as what Supermicro can provide within the same form factor with some additional functionality. So if you take a look at something like this, we have a platform. This is based on Intel architecture with multiple OCP 3.0 mezzanine cards supported. And here you can see the size of these are actually a full 1U height, like a double stack per se for all the networking. In this case, we have more than 30 network controllers, which actually is used for edge aggregation of the data. At the same time, again, this is if someone were to swap any of these network modules, it becomes relatively easy because all of them are externally accessible, and these are based on OCP 3.0. Again, like with anything else, we are adding lot of products, and we are developing a whole bunch of these different platforms to support these OCP mezzanine cards, whether it is a single 1 gigabit Ethernet going all the way to 100 gigabits Ethernet and beyond, depending on what the market would demand. So we are expanding the product portfolio to support all this. as we try to keep things green and efficient, which is what I started with, resource saving becomes an important factor. So in addition to having a system supporting, very efficient power supplies and the cooling and other mechanisms to run it very efficiently over a period of time to reduce the operating expenses as a TCO, that is one side of it. The second part of it is how do we reduce the bill of materials and reuse any of it over a period of time. This is where the resource saving architecture comes into picture. So where we are able to use parts of the design. You don't necessarily need to upgrade or update the compute, storage, and networking all at the same time. We'll be able to separate it out and based on our own needs and how the refresh of these components come in, we'll be able to refresh at that time. That's how we are able to reduce not necessarily the total cost of ownership, but what we call it as a total cost to environment. We'll be able to reduce the amount of toxic wastage that is going to be coming from dropping these systems once they are completed their life. What we have also seen is a heavy demand in supporting higher and higher wattage processors and as well as co-processors, whether it's GPUs or FPGAs or other type of accelerators. And in order to do that, in addition to what we are able to do in a forced air cooling environment, we are adding other things such as a different type of liquid cooling. In this case, we are able to look at the processors and as well as the co-processors and be able to provide a liquid cooling environment, direct chip level cooling, whether it is in a data center where they have chillers where you can have direct liquid cooling, or you could deploy it in data centers who have a need to basically manage them without any chillers. Means you have liquid to air type of cooling where you take basically the heat dissipation within the rack elsewhere. That way the systems will be operational. So this is something that we are investing quite a bit of resource to enable customers to take any kind of a workload and deploy it anywhere. As I was mentioning, part of it is for the AI and deep learning type of initiatives. There are heavy need for a lot of GPUs and different topologies that people are going to be using. So we have the platforms which support either from a single GPU all the way to 16 GPUs in a single node. And depending on what kind of applications, they may have a standalone GPUs versus something that is heavily meshed together, like using NVLink, 16 GPUs connected with NVSwitch and all that. So these are going to be supporting these initiatives. The storage is another very important factor, in which case people are looking at not just necessarily the capacity, but also the throughput and performance, whether it's latency, whether it is I/O and whatnot. Supermicro invests heavily and working with industry leaders such as Intel and several other technology partners in bringing either E1L or E1S for a small form factor versus a standard U.2 drives, which actually are quite prevalent in the industry, and we support all of them, including hot pluggability in many platforms in order to provide the right storage mix for customer applications. OpenBMC is one of the key initiatives that is driven by Open Compute standards, and we are supporting that. And as a part of it, we are working with several customers, and we are working closely with them, and also getting these certified and making it work with several platforms of Supermicro. As I mentioned, whether it's a Cloud DC or Mega DC, these are the platforms where we started initially working with OpenBMC project, because these are the ones we are expecting it to be populated in majority of the hyperscalers and tier 2, tier 3 cloud service providers, where all these people can benefit from the open compute initiatives. System management tools point of view, mainly we have a BMC, and in order to support systems out of band, especially when they're deployed in a massive scale, the easiest thing for us would be to actually work on, again, industry standards. Redfish API is what we support across the board, and people can use that and integrate into their own system management utilities. Currently, the Redfish version 1.8 is what we support, and we continue to enhance these tools as the customer demand arises. System management tools go further in order to provide security, which is one of the key pain points for many customers in industries. We are doing hardware root of trust on all these platforms, and we work with the BMC vendors as well as the technology vendors such as Intel and incorporate that into that. So in addition to root of trust, the standard systems, whether you want to make sure the BIOS and firmware is signed and it's actually safe, and if something gets tampered, how do we make sure that we have a backup image which cannot be tampered with, and trusted platform module for people who are looking at incorporating security standards within that, enabling self-encrypting drives and things with respect to FIPS compliance and whatnot. So what we are trying to do is take the industry standard x86 architecture, incorporating into our platforms in a standard 19-inch rack mountable form factors, whether it's 1U going all the way to 10U, adding systems with the GPUs and the right amount of network and IO mix, bring certain NVMe and high capacity storage to enable customer to size the platform right for the given applications with ISV certification, so people can use these systems in their data center, and while they do so, be able to save not just on the capital expenditure, but also on the operating expenses as they move forward, not across one, but multiple generations. With that, I'm going to conclude this presentation. And for any information, you can visit Supermicro website, supermicro.com, where you can get all the information about what we are doing with the latest technologies and what we are trying to bring it to all of you. Thank you.
Good day, this is Balan Shanmuganathan, and I'm the Director of Sustainability at Seagate Technology. The demand for a sustainable data sphere, one that is reliable, fast, secure, and scalable, is as high as ever, and Seagate is committed to serving it. There are various aspects to managing a sustainable data sphere, and today I'll be touching on the environmental aspects. During this session, I'll provide a short introduction to set the context and then cover the three main environmental aspects related to producing, using, and disposing of storage devices. Let's start with the introduction. For those of you who aren't familiar with Seagate, we are a storage solution company producing hard disk drives, HDDs, solid-state drives, SSDs, and systems which incorporate HDDs and SSDs paired with software. We are vertically integrated with design and manufacturing capabilities in-house, while some of our products are contract manufactured through a third party. We operate globally with approximately 42,000 employees. And for more information on Seagate, you can visit our website. I want to start by first sharing our corporate values. When we talk about doing the right thing, we within Seagate are guided by our corporate values of integrity, innovation, and inclusion. The integrity value details our commitment to people, planet, and profitability. It's our values that motivate us in going beyond compliance to doing right by the planet. Guided by our values, we have made a few voluntary commitments. Our formal Global Citizenship program took shape when we committed to the United Nations Global Compact in 2004. We committed to abide by the 10 principles and to drive improvements within our sphere of influence. As an industry, we came together as the Responsible Business Alliance, formerly known as the Electronics Industry Citizenship Coalition, and we committed to the RBA Code of Conduct ourselves and adopted the code as our supplier code of conduct. The code sets standards in the 4 areas of labor, health and safety, environment, and ethics with a management system approach to ensure programs are sustained. Seagate is a founding member of the organization. Our most recent commitment was in 2019, where we signed up to setting science-based targets for the reduction of greenhouse gases. We have committed to reducing our greenhouse gas emissions by 20% by 2025 and 60% by 2040. These commitments are important to demonstrate our intentions to our stakeholders. Next, let's move on to operational sustainability, which looks at how we are performing in our own operations relative to greenhouse gas emissions, water, and waste. This is an important aspect as we do a lot of manufacturing in-house. Starting with greenhouse gas and energy. Greenhouse gas emissions and energy has been identified as the most significant environmental aspect of our operations. We've been working on energy reduction activities for decades, and since 2007 started tracking our greenhouse gas emissions and built a more comprehensive program around greenhouse gas emission reductions. In calendar year 2019, we reduced our absolute emissions by 1.2% and intensity emissions by 19% compared to the previous year. We recently obtained our multi-site ISO 50001 Energy Management System certification. As I had mentioned earlier, we have a long history in energy conservation, resulting in 187,000 megawatt hours of electricity saved since 2014. We have also installed on-site renewable energy generation capabilities at our Fremont and Singapore sites, resulting in approximately 1,000 megawatt hours of clean energy generated in fiscal year 20. We continue to look at opportunities to expand our on-site energy generation capabilities. We also publicly disclose via the CDP Climate Change Questionnaire, and in 2020, we were recognized for our leadership in this area by being included in the A list. Our programs align with the Sustainability Development Goals, or SDGs, and this in particular aligns with SDG 7 on clean energy and SDG 13 on climate action. Next, we move on to water. Seagate operations are not water intensive. However, water is a critical resource to support life on Earth, and we recognize that. We have been working on water conservation and recycling for a number of years. In calendar year 2019, we continued to reduce the amount of water withdrawal by 3% and 19% reduction in water intensity compared to the previous year. We recycle approximately 2,775 megaliters of water, which amounts to 1,110 Olympic-sized swimming pools. All wastewater is treated to exceed regulatory discharge limits. We also publicly disclose information on our water program via the CDP Water Security Questionnaire, and in 2020, we achieved a score of A-. Our water initiatives support SDG Goal 6 on clean water and sanitation. Third and final environmental aspect of our operation is around waste. As a manufacturing entity, we use and dispose of a lot of material and chemicals. In fiscal year 20, we recorded an increase in overall waste generation due to certain decisions that we took intentionally. Although the absolute waste increased by 4.3%, our waste intensity reduced by 16.4% compared to the previous year. We have made a commitment to zero landfill of hazardous waste and are working on recycling as much waste as we can. We currently recycle 87% of our hazardous waste, and 87.8% of our solid waste is diverted from landfill. The Waste Reduction Program is a key program under our ISO 14001 Environmental Management System. The efforts around waste is in support of SDG 12 around responsible consumption and production. Product stewardship is critical in not just meeting customer requirements, but taking responsibility for the products that we place in the market. Most of Seagate's products are integrated into larger customer systems, and we work in partnership with many of our customers in understanding the environmental impacts of our products. Quantifying the environmental impacts of our products is key in identifying how to better manage and reduce those impacts. To do this, we commission life cycle assessments or LCAs of our product families and publish product sustainability reports. These assessments employ established methodologies and are third-party verified in accordance with ISO 14040 and ISO 14044 standards. These assessments look at the complete product life cycle from the bill of materials to the manufacturing, packaging, transportation, use, and disposal of the product at the end of life. Our customers have reached out to us for information as they conduct LCAs of their larger systems and have been complimentary of our efforts. The product sustainability reports are available on the Seagate public website. Next, let's look at some of the environmental impacts. Of the 15 impacts that are assessed in a typical LCA, we have found climate change, metal depletion, water depletion, and human toxicity as being material to our products. We have been doing these assessments for several years, which allows us to trend how we have performed on these aspects. Generally, the innovation around storage capacity growth has contributed positively to reducing these impacts on a per terabyte year basis. Over the last decade, we have been able to reduce the impact in these 4 areas by between 79 and 87% on a per terabyte year basis. We continue to innovate by increasing the storage capacity of our products with small increments in input. The product impact improvements support SDG Goals 6, 12, and 13.
Well, that's the end of the 2 sessions. I truly hope that you enjoy it. Thank you for coming. Bye-bye.
My name is Laura Poser, and I'll be facilitating the question time today. So on behalf of DiGiCOR, I just want to thank our speakers again. Climate change is a defining issue in our time, in which we all need to work together to address. And it's so wonderful to see think tanks like Beyond Zero Emissions and companies like Seagate and Supermicro who are working towards reducing the impact we have on our environment. So we'll open up to questions now, and for questions we have here with us today, and I apologize if I mispronounce, we have Dr Chun Hin Ng from Beyond Zero Emissions, we have Balan Shanmuganathan from Seagate, and Des Nguyen from DiGiCOR to answer questions on behalf of Supermicro. So I'll first start off with Chun Hin with the first question, if you would like to put on your microphone. Thank you.
Yes, sorry about that.
Oh, you're fine.
Yes, I'm here.
Hi, welcome. Thank you. Thank you for your presentation. It was
you're quite welcome. Do you want me to turn on video as well? Oh, there we go.
Okay, thank you.
Yeah.
So our first question. So has COVID impacted the development of renewable industrial precincts and the timeline for which Australia has to reach zero emissions, do you think?
Well, actually, it's a funny thing about that. It's actually maybe more the other way around. Because of COVID, we ended up going and developing these ideas because it offers such a, I mean, it's horrible to be sure, but it really did give us a sort of like a reset button to be able to sort of reposition and repivot about what we thought about how our economy worked and what was possible, because COVID really showed, you know, when push comes to shove, we can adapt quite a lot. And, you know, with most of the economy down, there was a real opportunity for us to sort of move towards a more like green recovery. And so that was what our Million Jobs plan was focused on. And it got amazing reception, like I mentioned. And that renewable energy industrial precincts built off that as well, because the manufacturing sector was quite badly hit. And we saw an opportunity there to sort of provide these options. There's amazing opportunity really for them to sort of reposition themselves to move towards this zero emissions manufacturing. And of course, like that includes the IT industry there and all the opportunities that they can provide. So it's really the other way around. COVID actually allowed us to really rethink and reposition ourselves. So that's probably one of the best things to come out of it.
Yeah, one of the best. Yeah, one of the upsides of COVID.
Yeah.
Wonderful. Thank you. So our next question, what is your opinion on Australia's gas transition plan towards renewable energy?
Look, I will say once upon a time, maybe, 10 years ago or something, there was a real big scope that we needed that gas to come online to sort of be that transition. But given the way technology has moved, especially with energy storage, say for batteries, and also how the gas prices have, continued to increase as we sort of exhaust the remaining, conventional cheap gas. And now you really have to go into the more expensive, whether it's fracking or sort of more deeper sea kind of gas reserves. Like that cost benefit isn't there anymore. Plus batteries, in terms of competition, is way up there, and the response times for batteries is so much better than gas generators that their role in the overall grid in terms of smoothing and peak power, that peaking ability for those gas plants they're sort of becoming obsolete. And so that's the truth that we've seen. But obviously there's a lot of like political issues that surround it, and that needs to be discussed. And obviously there's big industry players that have invested a lot into gas, and it's not it's not as bad as coal for sure. But like the idea of using gas as a transition, it really is kind of like, that time has passed, and now renewables and batteries and energy storage, the cost for them is so much lower than it was 10 years ago, that there's really no reason why we don't just go straight there. Like, why transition when you can just go to the final product, So yeah, that's my main thing. And the difficult part now is to just convince everyone else. And most people are on board, but obviously, it's a hot political topic.
Yeah. Well, thank you so much for sharing your opinion on that.
That's kind of right.
And our final question, do you think edge computing will help with reducing emissions or not? Because as we know, edge computing means more electricity consumption.
Yeah, I guess this ties into some of what the other speakers mentioned. Like overall, computing is going to remain a big part of our lives, and so any sort of efficiency improvement that we can make is going to help. I do think overall, like I'm not as familiar with the whole sector as you guys obviously are, but like I do think that the benefits that they bring in terms of being able to optimize, every system, both for energy and just a whole range of, just productivity, it is more useful than not. And the fact that they run on electricity is a massive benefit, because you can power all of that through renewables. And like in Australia, we have the capacity for it. We have no shortage of renewables. It's just we need that infrastructure behind it. So rather than, more electronics and stuff, it's more like, hey, let's get the infrastructure out there so we can really make the most of this.
Wonderful. Thank you. Thank you so much for your presentation today.
All right.
Great, and we appreciate it.
Thank you for inviting me.
All right, I'll pass over to Balan now, the Senior Director of Sustainability from Seagate. Balan, are you there? Hi, Balan. Thank you again for your presentation. So I've got some questions here for you. The first being, how do you keep your channels in line with Seagate Code of Conduct? So do you have any auditing procedures?
Well, as I said, we do a lot of manufacturing in-house, and so we do have corporate procedures on what the sites have to adhere to, but we are also held to the standard by our customers as well. So we do have industry-led verification processes where we subject ourselves to audits to demonstrate to our customers that we meet their expectation from an environmental perspective or from a CSR perspective. Similarly, we do employ similar tools and processes that are accepted by the industry to monitor our supply chain as well. We are fortunate, in my opinion, the ICT supply chain is fairly mature compared to other industries like garment and toys and stuff like that. So we are fortunate that our supply chain is much more mature. We do have a higher level of understanding and acceptance of how to operate more responsibly. So of course there's always some more challenging suppliers, but nonetheless we tend to partner with and demonstrate and support our suppliers in getting to where we need them to be.
Wonderful, thank you. I'll just see the other questions. So we've got another question here. How do you monitor your emissions? Do you use sensors or edge computing solutions to help you with that?
Well, our emissions, we've got direct, indirect. I mean, majority of, if you look at Seagate's profile, you look at scope 1 and scope 2, 75% of our emissions is from scope 2, which is from procured utilities. So which is very easy to measure because we've got metering, because we pay the bills, right? Be it chill water in some places or majority of it being electricity. Scope 1 is a little bit more challenging because we talk about what's emitted in-house, and majority of those are processed chemicals and emissions, which although we have recovery systems in place and what have you, about 25% of that comes from our own operations. And so we do have systems in place to track those. We are in fact implementing a new application across the company to further refine how we can track this information at a more machine level, so we can actually then start comparing between tools and seeing why one is using or emitting more than the other when they're supposed to be identical processes and stuff like that, so we can get better at that. And then of course the other piece is the whole scope 3 emissions. So there you do a lot of modeling, and if you look at Seagate's overall footprint, our largest contributor to greenhouse gas is in the product use phase. And so that's where we tend to work now with our customers. Fortunately, a number of our larger, we talked about data centers and power use. Again, most of the large CSPs or cloud service providers are on renewable energy, which is good. And so and that's a positive to the whole thing, but nonetheless, we do work with our customers and seeing how we can better manage power from a storage perspective to give them more storage for the same amount of power, right? So if you look at the progression of watts per terabyte, you will see that the terabyte has increased tremendously for the wattage that you need now to power that. So that's positive, but of course we still can improve further.
Wonderful, thank you so much. And I'll just check our last few questions. I think they might have just covered them. And I think you've managed to cover the last questions. Thank you so much for that, Balan. We really appreciate your participation in today's event. Thank you.
Thank you.
I'll pass over now to Des Nguyen from DiGiCOR on behalf of Supermicro. Des, are you there?
Yes, Sam.
Hi, Des. Thanks for joining us.
No problem.
So I've just got a question here. So in your opinion, would virtual desktop infrastructure and hyper-converged provide a seamless experience to the employees? Or is it still relevant to provide a high-end workstation to staff?
Again, it really depends on the requirements of the users and customers these days. Like, given the advent of COVID and everything else like that, that's deeply affected the market, and the amount of staff that are working from home now, virtual desktop has seen a big push there, especially, in there's a lot of pushback in recent years, mainly due to the costs associated with such deployments. But with COVID, advancing like a more flexible working place, virtual desktops certainly have carved their way into the market space. But there'll still be certain applications where the virtual desktop is quite prohibitive in terms of like high performance workstations and desktops that are quite CPU or graphic intensive or whatnot. Those, that particular segment of the market still requires a physical system under your desk that's doing all the groundwork. But a majority of office workers and power users, like the adaptation of virtual desktop is definitely prevalent in that area.
Wonderful, thank you. Thank you for that response. So that's all the questions we have for Supermicro at this stage. I think that concludes today's session on green computing and Industry 4.0. I really appreciate all of the speakers coming on board and all of our guests as well. I'm not sure if Richard would like to say some last few words, but is Richard there? If not, that's...
Yes, I am here. Yeah. Again, thank you very much. As you put there, thanks for all the guest speakers and also the participants. I think the last 2 days, even though just 2 hours, has been very informative, at least to me. Zero emission target, I think it is a big target to achieve. I'm glad to see that all the key vendors that DiGiCOR is dealing with has an initiative in this particular area. And thinking about devices, yesterday I mentioned there are 2% emission generated from data centers. That's not including the devices. I think there are 50 around the world. Currently, there are 50 billion devices. If you take that into consideration, it will be enormous emission. So I'm really glad everyone in this industry has taken that initiative, and DiGiCOR is part of it. So thank you very much. Thank you.
Thank you, everyone.